So notice the last kind of asymptote is a slant asymptote. And slant I like to think of as special. It's that one that has the special name too. So it's also called an oblique asymptote. And it's a slant line, so it's a diagonal line across the coordinate plane. And that means it can be written in y equals mx plus b. Slant asymptotes occur when the degree in the numerator is equal to the degree in the denominator plus 1. So when it exceeds the highest power in the denominator by exactly 1 in the simplified function, which means once it's all canceled out and all of the factors and the vertical asymptotes have all been found. So this means that the degree in the numerator is equal to the degree in the denominator plus 1. So let's look at these examples of functions with slant asymptotes, and I'll do one example with you. You can do the other one. So we see here that x squared minus 4x minus 5 is in the numerator, x minus 3 is in the denominator, and even though we can factor out x squared minus 4x minus 5, so over here you can factor it, even though we don't need it, it's still good practice. So factor x squared minus 4x minus 5, and then why don't we need it? So you can answer that over here. So we've got the numerator and the denominator, and the degree in the numerator is 2. So the degree in the numerator is 2, the degree in the denominator is 1, and that is equal to 1 plus 1. Right, so we know we have a slant asymptote here, which means we need to divide. So slant asymptotes, oblique asymptotes, they have to be special, and we need to divide. So we're going to divide, and they're slant, so they're diagonal. So if they're diagonal across the coordinate plane, then we divide. Diagonal, divide. So I'm going to show you two ways to divide. They both work every time, whether or not you have remainders. The first way I'm going to show you is by long division. So I'll show you long division over here on the left, and then I'll show you some exploding dots on the right. So long division means we put it in the house. We put the denominator outside the house and the numerator inside the house. And then the first thing we want to do is divide the first term in the inside by the first term on the outside. We get x, that goes up top, and then we multiply this by everything on the outside. X squared minus 3x. And just like if you were dividing by long division just with numbers, you subtract these. So I'm going to subtract, and I get 0, and I subtract this negative 3x, and it becomes a positive, and I get negative x. Bring down the negative 5, and then we do the whole process over again. Negative x divided by x is negative 1, and there will be a remainder because when we multiply this again by everything on the outside, we get negative x plus 3. So there will be a remainder of negative 8. So this is plus negative 8 over x minus 3. But we don't even need the remainder. The slant asymptote is the linear portion before the remainder. So when you divide here by long division, when the degree of the numerator exceeds the degree of the denominator by exactly 1, after you've simplified and all of the factors have been reduced and you found all of the vertical and horizontal asymptotes, you can see here that the slant asymptote is at y equals x minus 1, the linear part of the quotient before the remainder. Now you can find it this way. Long division's easy, it works every time, but you can also find it by exploding dots. So you've got this relationship up here, this functional relationship of x squared minus 4x minus 5. And you've got x's, x squareds, you've got x's, and you've got some integers. You've got ones, 1 units. And you've got 1x squared. You've got the opposite of 1 positive x squared, which is negative 4x's. And then you've got negative 5's. So it's the opposite of the positive. A positive is just a filled in circle, dot, and a negative is the open one. No filled in, negative space. And division, all division means is grouping. We're just making groups. And so when you divide, you've got the numerator and the denominator. The numerator is the thing being divided, and the denominator is the groups. So we're dividing x squared minus 4x minus 5 into groups of x minus 3. So into groups of 1 positive x next to 3 negative units, dots. And once you make it like this, then it's just dots next to each other. So I want 1 positive dot next to 3 negative dots. And I see that in this first part, 1 positive dot next to 3 negative dots. And I make a check mark in my x's. I've got 1x. And then you can make opposites. So a negative x minus 3 is just the opposite. It's an open circle with 3 closed-in circles. So look, I've got an open circle in my x values, and then I would have closed circles over in the ones values if I had some, and I need some closed circles, so I'm just going to make some because it's math and I can do whatever I want. But I have to pay for the consequences afterwards. So in math, whatever you do to one side, you have to do to the other. I've added 3 positive ones, so I have to add 3 negative ones because I can only add 0 at a time. I've effectively added 3 0 pairs, 0 3 times. And then look, we have our pair that we need, and it's a negative 1. And so we get the exact same function here if we count this check mark in the x part as a positive x, because we made a positive group, and then we count this negative check mark as a negative 1 because we found a negative group. So 2 ways to divide, 2 ways to find slant asymptotes if the degree of the numerator exceeds the degree of the denominator by exactly 1 after everything is simplified.